Carnival Cruise Lines is proud to present you with a very special tour. Have you wondered how the ship is piloted and controlled? Have you asked yourself, how does this thing actually go? Well, we'd like to take you behind the scenes of this technological masterpiece and show you the brain and heartbeat of your Carnival fun ship. This vessel is one of 8 Fantasy-class sister ships, all built at the same design in Helsinki, Finland. The Fantasy first sailed in 1990, and the last ship in the series, the Paradise, set sail just 8 years later. Your ship is 885 feet long and 118 feet wide, making it nearly as long as 3 football fields. She rises 13 decks over 130 feet from the keel to the top of the volleyball court. That's just slightly taller than the Statue of Liberty. She is part of a class of cruise ships called superliners because it is over 70,000 gross registered tons. Gross registered tons is a measurement of the interior space, not the ship's actual weight, as it might imply. It cruises at about 19.5 knots and has a maximum speed of 22.3 knots, very fast for a ship this size. A knot means 1 nautical mile per hour, roughly equal to 1.15 land miles per hour. Now, doing 20 miles per hour may not sound very fast, but when you do that continually for 24 hours, you can cover a lot of ground, or water for that matter. Your ship can accommodate over 2,000 guests and has a crew of 920 ready to serve you. Before we start our tour, let's define a few nautical terms. If we look at a model of the ship and face the bow, we are looking at the forward part of the ship. Behind us is aft. To the left is port and to the right is starboard. These terms are used to accurately define a place on the ship. You would never say another ship is on the left side, but you would say another ship is on the port side. This helps to avoid unnecessary confusion. And now, it's off to the bridge. The bridge, or wheelhouse, is where the captain and his officers pilot and monitor all the maritime functions. It is generally near the top of the forward section. This ship has a totally enclosed wheelhouse with wings that extend over the sides for an unobstructed 180-degree view. At any one time, there are at least 4 people on duty on the bridge. This may or may not necessarily include the captain, but includes 2 senior officers and 2 quartermasters. The officers plot the course of the ship, while the quartermasters will physically steer it. Let's take a look at the equipment and systems used to accurately and safely pilot a Carnival fun ship. In the center of the bridge is the main manual control for ship's speed and thrusters. There is still an actual wheel for steering, but there is also a joystick control. A computer translates wheel and joystick movements, and movement commands are relayed to the azipods. The twin azipods are normally synchronized to turn together, although it is possible to lock one pod for more precise maneuvering when docking. Separate levers control the speed of the main engines and thrusters. The azipods move the ship fore and aft in the water, while the thrusters move the ship from side to side during docking and turning maneuvers. On the far port and starboard sides of the bridge are duplicate pilot stations for maneuvering in and out of port. From here, it is even possible to look down the side and see how close the ship is to the pier. Starting on the port side of the bridge are weather indicators, emergency radios, and engine room monitors. The weather fax receiver prints information transmitted by more than 50 worldwide weather stations. There are 2 of these fax receivers, plus the ship can receive weather bulletins by email and the Global Maritime Distress and Safety System. The main purpose of the GMDSS is to alert coastal stations and all nearby ships if the vessel is in distress. This reduces vital search and rescue agency reaction times. It consists mainly of radio and satellite navigation transceivers and portable VHF radio equipment. Next to all of that equipment is a computer monitor that relays information of engine room systems. This way, the bridge can see the status of the diesel generators, azipods, air conditioning, fresh water, and ballast control. The engine room itself monitors all of this and makes any corrections necessary for the proper operation of these systems. Indicator panels give the status of the navigation lights and stabilizers. All vessels are equipped with navigation lights, fitted on the upper decks, funnel, mainmast, and stern. Red and green lights are fitted on the port and starboard sides respectively. All of these lights inform surrounding vessels of the ship's heading. Stabilizers are 15-foot-long retractable fins, which help steady the ship from rolling side to side in heavy sea conditions. They can help reduce roll by as much as 80%. Finally, on the port side, there is a draft meter showing how deep the bow and stern are in the water. These readings can also be taken visually for complete accuracy and are used to keep the ship properly balanced in the water. A fantasy-class fun ship generally sits about 25 feet in the water, about average for a vessel of this size. On the starboard side of the ship is the station for charting the course and programming the autopilot. The autopilot is in control for about 80% of any voyage. The officer on duty uses paper charts to determine the ship's course, then enters it into the voyage management system. The VMS uses two different global positioning systems and a Loran C navigator system. The GPSs use 24 satellites in geostationary orbit around the Earth to determine the ship's position at all times. When maneuvering 12 to 24 miles from the coast, radar is used to verify the position of the ship against the GPSs and the Loran C. All of these systems use their own separate antennae. Because of these double checks, the ship is never more than 30 to 45 feet off the computer-stated course. There are 3 important radar systems on the bridge. 2 of them have a range of 48 nautical miles and can track up to 20 other vessels. The third system has a range of up to 96 nautical miles. All of them have the capability of steering the vessel under autopilot control in up to 3 different ways, by heading, course, or track. This means the radar computers can track the course of other nearby vessels and alert the bridge crew when another vessel approaches. The starboard station includes a course recorder, which keeps a 24-hour record of the ship's course and applied rudder. Just like the black box in an airplane, it records every movement of the ship for later reference. Also, here is the Doppler speed log. This uses sonar to determine the depth of the ocean beneath the keel, as well as speed and course. Normally it is not used in open seas, but by regulation it has to be active when entering or leaving harbors, or whenever in shallow water. And finally, this station contains all of the bridge's radio and telephony equipment. From here, the bridge can contact any place on the ship and call by satellite any place on land. The VHF radios are mainly used for short-distance communication, ship-to-ship or ship-to-shore. In the portside aft section of the bridge, we have all the safety-related status and control panels. These panels show the location and status of fire alarms, sprinklers, fire dampers, and low-level lighting. The watertight door panels show the status of all the ship's watertight doors below deck, which divide the ship into several separate watertight compartments. In the unlikely event of a hull breach below the waterline, flooding is minimized by completely sealing off any single compartment taking on water. This way, flooding is minimized and the ship remains stable on the water. Opposite the safety panels on the starboard side of the bridge are 2 gyro compasses. They are completely isolated from all other systems on the bridge. They provide a constant course reading and are checked against other navigational equipment. Now, let's go below and take a look at the engine room. The engine room of this ship has some of the most advanced systems available today, most notably the Azipod propulsion system. The Azipods each contain an electric motor and propeller in a configuration not unlike an outboard motor. The idea of using an electric motor inside a submerged propulsion pod has been around for some time, but it was not until the late 1980s the first practical podded main propulsion system was developed. These systems have been on ice cutters and other vessels for several years, but the Carnival Elation is the first passenger ship to be equipped with Azipods. Both the Elation and Paradise are equipped with two Azipods containing electric motors with a total power output of 14 megawatts, capable of up to 18,766 horsepower. They can be turned in any direction in a 360-degree radius. Therefore, any amount of thrust is available in any direction desired. The result of this is the absence of stern thrusters and increased maneuverability at any speed. All electric power necessary for propulsion and the other services of the hotel department, such as air conditioning and lighting, is produced by 6 12-cylinder diesel engines, producing a total of 48 megawatts or 63,343 horsepower. This is a lot of energy, capable of powering a small town. At least 2 of these 6 generators are dedicated to producing power for the Azipod propulsion system at any given time. In addition to supplying power to the Azipods, the diesel generators produce electricity for all other areas of the ship as well. Because the Azipods are self-contained, the engine room has a great deal of extra space, normally taken up by stationary engines and huge propeller shafts. We have filled that space mainly with larger and more efficient chillers that provide air conditioning for the ship and cooling for food stores. On this ship, this equipment is now all centralized in the engine room and is rated green for operating within new environmental guidelines. Another environmental improvement is the addition of 2 enhanced incinerators. Some garbage is still offloaded in ports, but more can be incinerated on board than previous vessels. Our vessels never discharge garbage while at sea, even though international law allows this. Plus, the incinerators each produce an additional 1,200 kilowatts of electricity. This engine room also carries the latest versions of other standard equipment. Evaporators provide fresh water from seawater. They each provide 650 cubic meters at a time, and the total capacity of freshwater storage is nearly 1 million US gallons. Managing sewage treatment is even easier than before. Sheets of biological filter material help separate the waste, and other compounds sterilize the water. Even though the water is used for cooling and cleaning, it is biologically clean enough to drink. Another system important to the comfort and safety of the guests are the stabilizers. The stabilizers fold into the ship's hull from the bow aft. When extended, they act like paddles and steady the ship from rolling in moderately rough seas. The stabilizers are hydraulically controlled from the rooms on each side of the ship. We can see by the indicators here how hard the stabilizers are actually working. All of this is monitored and controlled in the engine control room. The 2 most important systems here are the power management system and the in-touch computer controls. The power management system monitors and controls all aspects of the propulsion system. Everything about the power generators and Azipods are controlled from these touch screens. The in-touch system controls everything else considered auxiliary to the propulsion systems: the incinerators, water chlorination, electric distribution, sewage treatment, and the whirlpools on Lido deck. For normal operation, there are no bulky manual controls. The engineers simply touch computer screens for the control they want to activate, and automatic servos take care of the rest. This is the ultimate evolution of engine room control. Since the computer touchscreens are a remote control for the entire engine room, there is no need for the engineers to spend all of their time around noisy, hot equipment. While the systems and engineering of the ship are state-of-the-art, no vacation would be complete without the dedicated team on board ready to serve you. After all, a ship is only as good as its crew. We hope you have enjoyed this tour behind the scenes Carnival Fun Ship and wish you smooth sailing.